everyone, and welcome to our webinar series Rutronik Connects. This week we are currently in our last week about Bluetooth technologies. Today I want to welcome KYOCERA AVX and Jens Kattenbusch with his theme Bluetooth antennas and interpositioning with BLE. On the left side you can see me, Tobias Luschhey. I'm a corporate product manager within the wireless department of Rutronik. And as I said, I want to welcome Jens Kattenbusch from KYOCERA AVX. First of all, some practicalities. Our webinar will go roughly 1 hour. Questions are, of course, welcome. You can type them on the right sidebar in the Q&A. We will answer your questions at the end of our webinar. If you have further questions, you can always contact us anytime. I will tell you later about it. The presentation and the slides will be recorded, and you will receive the slides and the recordation afterwards. So again, hello Jens. You can share your screen.
Thank you, Tobias. So thank you, Tobias, and thank you for the Rutronik team to allow us to present the Bluetooth antennas for locationing and positioning specifically. My name is Jens Kattenbusch and I'm the Regional Technical Sales Manager at KYOCERA AVX, responsible for RF products, antennas, and some passive components for RF. I'm located in Germany and taking care of the Central and Eastern Europe region. In case of any questions, you're always welcome to connect. In this presentation, I want to start with a little bit of background on our antenna portfolio. So we came from the custom antennas, having a lot of own patents and own patented designs for passive and active antenna systems. We are globally equipped with many different chambers for all kinds of technologies, having state-of-the-art antenna and manufacturing technologies. We established a very broad portfolio on standard antennas by now as well, and that's what I want to go through a little bit more detailed with focus on the Bluetooth direction finding. So here you can see our locations for Europe. Our closest office and design center is in France, close to the Nice area, but we also have our US office and multiple offices in Asia, Vietnam, China, Korea, and Taiwan. Design centers, but also the manufacturing sites. So we also do produce outside of China, in Korea, Vietnam, but of course some products are mainly coming from China, since that's the most common place to produce. In terms of applications, we have our industrial gateways, metering, smart homes, satellite communication, where we do offer a lot of technologies like cellular, LoRa, Wi-Fi, DECT, NR+, as well again, but also for wearables, and I think automotive and asset tracking, the BLE is coming more and more, especially for wearables. We do a lot of custom designs. In automotive, we also do a lot of custom designs, but also we have a lot of standard parts included in our antenna automotive series. So with extended testing for the automotive market. And especially here, we do see a lot of projects for Bluetooth, low energy, direction finding, and channel sounding. Talking about these technologies, I just put up some pictures from the Bluetooth SIG on how it works basically. So we have the angle of arrival or angle of departure methods. Typically we see the AOA method is being used by our customers. So you have a transmitter and the receiver measures the angles coming to each of these antennas in an array. So that means typically you have an antenna array or active antennas with multiple radiation patterns that you require to measure the phase distribution and thus the location of the transmitter. And the other way around for the AOD, angle of departure method. The next technology that is coming up, especially for locationing and also improving the BLE technology, is the channel sounding. And I just also here briefly put up the main parts of that in the slide here. So we have two parts, which is the phase-based ranging, PBR, and round-trip timing. In the phase-based ranging, the signal from device A is going through or is reflected by device B, measuring the angle and the phase at this point here, and then checking again when it's reflected and coming back to the initiator, to the device A, what is the phase, comparing it with multiple signals. So that's what you can see maybe a little bit better here. So you have a little bit faster signal in one channel and a little bit or even faster signal in another channel, having a different phase each. So this is being compared at the reflector, and thus you can measure the phase variation and the location of the device. And supportive to that, there is the round-trip timing part in the channel sounding, where just the time of flight between the devices is being measured from device A, reflected as well to at device B, coming back to device A. So you have each the different times or timestamps that each of these travels takes, and also can do the positioning with it. And what I noticed was that especially for the channel sounding, there's only 4 or 5 channels, I think, that allow channel sounding. So we have a reduced number of channels, plus the TX and RX time division is reduced, which means the antenna must be very, very good in terms of reliability to not fail in this very few amount of channels, to properly catch the signals and handle the signals. And the second thing is the phase variation needs to be detected. So also here, typically, also the Bluetooth SIG recommends an antenna array or multiple antennas for the detection of the devices. And another big topic, always for BLE, since it's a Bluetooth low energy part, one important thing is to save power. And these are some of the key parameters that we see for antennas on the antenna side that actually save a lot of power. Once the antenna is very, very efficient, including the losses, so you have, in best case, very low losses. We have a very good isolation, a very good gain, enough but not too much for each application, and overall the efficiency, the device power is being reduced. And we also do some active parameters checking and testing, just to make sure the total radiated power and the isotropic sensitivity are within range, just to make sure the device can actually be very efficient the way it works. And these are some topics I will come back later, introducing a little bit more about our possibilities for the services and measurement options that we do offer. So the low power part is quite important still, especially compared to ultra wideband, for example. I think these are the most competitive technologies in the field at the moment. So now I just go ahead and talk a little bit about the products that we can offer for each type of technology. So mainly we focus on the chip antennas for this direction finding and positioning on BLE. And we have a lot of different antennas for that. So smaller ones, bigger ones, depending on the location, which I will also introduce later. And to highlight a little bit our super small antennas, also here on the next slide, I will talk about that a little bit more. And generally, we have very, very tight tolerances. All our products for the chip antennas are SMD mountable. We have these corner placements, and as I said, also automotive series, which has been tested in the factory according to AEC-Q requirements. And some applications, especially for IoT tracking, industrial tracking, asset tracking, wearables, telematics, and so on. The positioning and the function comes in quite handy. And this is one of our latest products and product highlights. One of the smallest antennas in the market for BLE. It can be used for 2.4 and 5 gigahertz, so also Wi-Fi. But we have a separate layout only for BLE, so it's really optimized for this matter. And as I said, that's quite important when you talk about low energy, and of course also the functioning of direction finding and positioning, because the antenna needs to be kind of precise and reliable. You can find all of this information on our website. If you click on the portfolio link here, or if you just look for the antenna online, you will definitely find it. And I just added some pictures of our evaluation kit. So we always offer multiple evaluation kits for each antenna, one for BLE or Bluetooth only, one for Bluetooth and Wi-Fi, and even for this part, one for ultra-wideband. So you can really choose exactly the layout you want and you require to measure and to test. Other types of antennas we offer are the metal stamped antennas, and these we specifically, or we often use in the smart home environment because they are quite insensitive compared to other types of antennas on the noise factor. So especially if there's some metal surroundings or more complex surroundings, the metal stamped antennas, we have some great successes. And we have different sizes, different form factors, and different polarized antennas as well. They are also SMD mountable, so it's quite easy to integrate them. Usually they have this kind of through-hole pin here. And another advantage is that the clearance area is usually quite small. So I also have some more pictures on that side as well to prove it. And of course, they're cost efficient and usually also covering multiple technologies like Bluetooth and Wi-Fi, for example. Also, these you can find everything online, typically including some application notes on how to properly mount it, how to properly use these antennas. Additionally, we have our PCB FPC antennas plus cable. So these are adhesive antennas that can be mounted via this adhesive tape on any surface. We recommend usually plastic, but we also have one version specifically designed for metal surfaces. And we also have some tunable antennas that you can optimize for different materials, like glass, for example, or like plastic or other materials you might use in your application. Also here, these antennas are typically for 2.4, 5, 6 gigahertz, so including Wi-Fi technologies. Also new, we are using now the MHF locked connector. So there's a small slider that you can use to lock this part of the connector. So it's quite stable, especially in environments which are vibrating a lot or where there's the chance of coming off. It's possible also to unlock it and to remove it, of course. And that's also a quite nice addition to this portfolio. And by the way, the difference between PCB and FPC is the FPC is just a flexible PCB type. Otherwise, it's just a trace on these types of antennas. And it's very, very easy to use, very easy to mount. Also, we offer different cable lengths for each type of antenna, so you can always make sure to have the best solution for your device. Of course, there are certain limits, but at a certain cable length, the noise of the cable will be just too much, so it's not worth it, and another solution might be considered. This is our latest series. I just wanted to show it. So we have different versions with cable on the side, cable in the middle, different versions with just 2.4 gigahertz, 5 gigahertz, dual band, triple band, whatever is required. And also we have this AP, BP, and CP series, having different radiation patterns coming from factory, so you can also exactly choose what radiation patterns is optimized for your application, and even combine it, of course, especially for direction finding and locationing. This is quite handy if you can choose already the main orientation of the radiation pattern, where it has to be most efficient, and then you can combine also multiple antennas in an array, for example. So it's also possible with these types of antennas to do that, and then really cover the whole area, and cover the best range for locationing. Also, we do offer some external antennas. I just wanted to mention it here. We have indoor and outdoor versions. The outdoor versions are usually IP rated, typically IP67. Very few of them, I think 1 or 2 are only IP65, but that's typically enough, especially in the industrial world, where it's mostly being used, but also we have the option for outdoor. And also here different types with cable mount, with hinged mount or straight mount, and not hingeable mounts. Also different types of connectors, and also offering adapter cables, as we can see here, the RPSMA to MHF4L. Just as an addition to our portfolio, it has been added quite recently to the line card. So now let's go a little bit deeper in the positioning of the antenna itself, and some more technical details, how to choose the best antenna, and especially for locationing, what are the requirements here. And this is just an overview of a few antennas. It's not even all of the antennas. So we have our super small chip antennas here and here. One of them is being on the long side of the PCB, one in the corner. We have multiple ones on the right side of the corner, in different sizes and form factors. Also not only in the center exactly, but also a little bit above the center and below the center. We also have this vertically mounted metal stamped antenna, which is in the top left, in the bottom left corner of the PCB. And on the right side, we have design based on a larger PCB size. So this is typically 110 to 125 millimeters in length, while the smaller one is typically 60 to 80 millimeters by 40 to 75 millimeters. It really depends on each product, what is the optimum size, but we support every customer here in case he has questions on how to use it on different sized PCBs. And on the right side, we have the let's say bigger parts for the bigger sized PCBs. Also here having different possibilities to locate the Bluetooth antennas. And most of them are actually not only Bluetooth. Some of them are also for DECT NR+, ISM, LoRa ISM frequencies, 868, 915, or even cellular partially. And what the position defines in the layout is the phase variation. So we did some tests here with one of our recommended antennas for the phase variation. It's the 1,01013 FR4 material antenna, and in the different measurements we can see that the phase is shifting, of course, within the frequency band, from 2.4 to 2400 megahertz to 2405, 2410 megahertz. And here in each of these graphics we can see the phase shifts to 360 degrees, so it's not possible to cover a whole phase throughout this frequency range. And there are nulls in some directions where you don't have any signal. So that's quite important to know, especially when you talk about channel sounding, but also direction finding AOA, because typically on the linear polarized antennas, the phase is shifting and you always have a null in the design. That's why we recommend, and we did a lot of tests already for ultra wideband, also working on Bluetooth a lot at the moment, to have the same antenna like the 1.1312, either vertically or horizontally polarized. So you can really catch all of the signals from all of the polarization areas. Also this one we have for both orientations. These are both also Bluetooth and Bluetooth antennas, so they can be used the same way as for ultra wideband. We also have this 3-dimensional design for ultra wideband. For Bluetooth, it's coming as well. Otherwise, the patch antennas can be used the same way, so it's perpendicular to the PCB, so quite directional. Or we have these metal stamped antennas also for Bluetooth, as we have seen before. And here you can really pick the best polarization, and we always recommend not to put the antennas in an array next to each other, but perpendicular to each other, so you can cover both polarization ranges vertically and horizontally. And that's quite important for the phase variation. So the next topic is the clearance area, and I just wanted to mention it because the smallest antenna is not always the smallest solution in the design. So we have this antenna here, which is 3 millimeters compared to, it's barely visible, but I just took the pictures from the data sheets here, compared to our 1 millimeter antenna. And the antenna is smaller, but the clearance area here in terms of width is smaller compared to the smaller antenna solution. So here we are talking about around about 12 millimeters in total clearance length. And here we are talking about, well, 7 millimeters in clearance length. On the other side, the depth is also important. And that's just to show for different scenarios and different antennas. There is also different requirements. For the corner mount antenna, we recommend to have the whole top removed, the metal, so just to have the antenna here and some matching networks. These images are not in scale, by the way, so you have to check individually the data sheets. But it's just a hint on how to compare the antennas as well. And same for the metal stamped antennas. And as you can see here, for example, on the vertically mounted one, the clearance area is basically just the size of the pads where the antenna is mounted, and there's no additional clearance here. For other ones, there is a clearance needed, and this is our longer metal stem solution, which is the bottom mount, but the clearance area is barely longer than the antenna itself and barely has more width, so it's around 1 or 2 millimeters additionally to the antenna that is required for the clearance area. And that's also always important to consider when choosing the antenna in the end. Another topic which is quite important is the distance and the position from the corner. So we did some tests where the antenna is put in the top center, and then we moved it to the left and to the right. And we can see when the antenna is 15, 10, and 3 millimeters away from the right edge compared to 15, 10, and 3 millimeters compared from the left edge, the efficiencies are quite various. So it also depends on exactly the position on the PCB board, how good the antenna will perform, and, well, as I said before, how much power the whole device will consume, because the efficiency is just the input compared to output. On the right side, you can see different positions on the PCB. So that's also quite important because, as I said, we recommend for direction finding and for positioning to have this orthogonal layout on the PCB. But it comes with a price, and that is typically the performance. Or you can use different types of antennas which are optimized for each position, and that's up to the customer to decide how to use that. But here you can see the S11 parameters and the efficiency for each position in the device. So typically, the best position is the black one, where we can get the maximum efficiency. The frequency shift or the center frequency should be somewhere here. So that's quite good, but also position 4 in the center top is quite well aligned here. So it makes a difference. And this antenna, for example, you can use perfectly for both locations here, 1 and 4. I would recommend to cover the vertically and the horizontal polarized signals. Another effect I just wanted to highlight, we have shown it before a couple of times, is human body absorption, which we can also measure in our chamber in France. It makes a huge difference. We have a delta of 9 dB. In this case, it's not 2.4 gigahertz, but it's 868 megahertz range, sub-gigahertz range. And in free space, the antenna performs much better compared to beside a human head or hand. So that really is a point that needs to be considered when designing a product, if it will be close to a human body or animals or other surroundings. And other surroundings, we also did some tests for glass, plastic, and free space, just to check the material detunings. And this is one of our tunable antennas. So it is possible by adapting these bridges here, closing these bridges, or leaving them open, to shift the signal a little bit to the center frequency, which is required. But on plastic, where we typically define the antenna to be working the best, it's quite nice in the center frequency. On glass, the frequency is shifted to the left. On the free space, it's shifted to the right, and quite far actually. So we are talking about 300 and 600 megahertz. And just to mention here, the Bluetooth channel is 80 megahertz, so we are quite far away from that. So that also needs to be considered when choosing the antenna and when designing the antenna, that you might need to adapt the matching network to the material you are using. Another quite nice service that we offer is the composite gain measurements. So here we measure in a three-dimensional space the antenna pattern at, for example, 2.4 gigahertz, having different angles as well for one antenna and for another antenna. And as you can see here, in the phi gain is quite low. So in certain areas, the antenna will perform not very well. So the target is, of course, to compensate the worst areas of each antenna with another antenna, for example, in an antenna array. And this is what we can measure here, where we have a mixed pattern on the top left. And after optimizing the whole pattern, because here we still see there's a lot of losses or a lot of bad performance areas with very low gain in some directions. On the other side, it's a little bit better, but after optimizing both of them together in the same measurement, we can see there's barely any blue colored low gain areas. And we also print out these these 2D maps where we can see the different antennas, how they perform and how they actually compensate the worst signals in the joint design together. So that's optimizing really the connectivity of the product, and especially this will be more and more important for direction finding and positioning when you need multiple antennas, and especially multiple antennas in one design and in the same measurement. Another topic I want to mention here, especially for the arrays, is that we do these kinds of custom boards. We already have some eval boards for this part here for TX and RX antennas. We also can do all kinds of customized versions with all different kinds of parts. Since we have so many products, we of course need to focus on the most common ones. So feel free to always get in touch if you have a certain application where you need to have a certain product with a certain position, and then we can typically figure out the best way on integrating the antenna in such an array in a dual use device. And also I want to mention on the roadmap, we already have many more eval kits with some antenna arrays, and also we have some more products based on LDS technology, so similar as for ultra wideband, having I think 3 or 4 antennas in one design, so that also improves the whole process of integrating an antenna array in the end, because it can be just soldered immediately to the application, onto the PCB, and then you have a 4x4 antenna array for each device that you can directly use. Unfortunately, I cannot show it yet, but I would always recommend to stay up to date, maybe even follow our RF newsletter and check with us on exhibitions, that we can share all the latest news at all times. And yeah, that's basically what we are coming from, as I said in the beginning, from the design to manufacturing, supporting our customers from the beginning, reviewing the application and the PCBs of our customers, doing simulations, doing custom antennas, custom eval boards, whatever is required, having the proof of concepts, the mock-ups of new parts or of the customer's application with our samples, usually free samples, having the mock-ups tested in our chambers, doing the optimization, active passive testing, up to pre-certifications, where we do test the single FCC CE required bands, validation samples, all the reportings, all the documentations that are needed for automotive, for example, PPAP documentations. We also have some medically approved antennas that we can also support, especially for Bluetooth and Wi-Fi. And of course, the mass production and delivering the products in the end. And that's really, I think, quite interesting. And especially we can do that globally with our different teams in each location. So Europe, Asia, US, depending on our customers or on the design locations from our customers. So to summarize it a little bit, we have this nice selection checklist, how to choose the antenna. So first there needs to be checked how many technologies must be integrated in the device, not only talking about Bluetooth arrays or having multiple Bluetooth antennas, but also cellular, GPS, whatever is required. And especially here, we have the experience with cellular and Bluetooth that there is a lot of interference between these technologies. So we can also support, of course, the frequencies and frequency bands which must be covered, and especially for the BLE direction finding and channel sounding, this comes more and more handy, because, as I said, the channels are being reduced where channel sounding is allowed, and the performance in each channel must be very, very good and very reliable to make it work. The PCB size, as I said, and also the position of the antenna. What are the environments where the antenna is placed? Is it a free space, onboard or offboard antenna? What kinds of materials is the antenna maybe placed on for the external ones? And what is the end user environment? As I said, for example, if it's a body worn type, then the frequency must be matched, and the gain may be adjusted to have a certain range and have a certain distance to cover. Some more examples of custom parts, especially for challenging mechanics. We do these LDS antennas, but we also offer custom flexible PCB antennas. So it can be a small customization of a current product. When we have cable lengths, or when you require cable lengths which we don't have in stock, we can always customize it. The same with connectors, but we also do a lot of customizations, removing the cables and just using some spring contacts. And for the LDS, we do the whole engineering part, integrating multiple antennas in one device, and that's really the benefit of LDS, because you can integrate as many antennas as there's space on the plastic carrier. So these are very, very nice for antenna arrays. And as I said, on the roadmap, we have already the first LDS-based antenna arrays for Bluetooth Low Energy. So that's quite interesting, which is coming in the future. Otherwise, we do it already custom. So there's nothing really I can show here, unfortunately, since that's all custom and customer specific. Typically, in terms of quantities, we recommend LDS only for very high quantities, since the initial costs are quite high for the engineering and the manufacturing. But for PCB or FPC antennas or stamped metal antennas, we can do smaller customizations quite easily. And also here we can choose the factories on where to produce it if a certain location is required. Also here you can find out much more about the LDS technology. LDS is a laser direct structuring. So the plastic carrier is, the structure is applied and some oxygen is released from a special type of plastic. And then it's being put in a metal bath. So just the metal sticks to these activated areas. And then we have a structure which we can use for antennas, but also for wiring. We also have some applications where it's just used for wiring to save some cable space, for example. And coming closer to the end, some more parts on our design and test services. So this is one of our biggest chambers, which is located in France. That's our automotive chamber, where we not only do automotive measurements, but also all bigger products that we can imagine, like fridges, industrial devices, machines, industrial machines, everything that doesn't fit in a regular measurement chamber. We can do measurements here. We also can do active and passive measurements. As I said, we also have a millimeter wave measurement chamber, which we designed ourselves. So also here we can very often adapt our measurement chambers to special requirements, like for example, Bluetooth AOA or ultra-wideband specialty testing for the positioning. Same as for GNSS for outdoor locationing or millimeter wave. I also mentioned it here, the FCC CE pre-check and pre-validation. So customers can make sure the certification will be passed, because, well, it can be quite expensive once this is being failed, because then typically the antenna has to be redesigned. There needs to be another antenna, maybe a completely different antenna technology. There's a lot of redesign efforts, plus time, plus costs, and additionally, usually you have to pay additionally for the tests to do the recertification and retesting. So we recommend always to have this checked out in our facilities, because it will be cheaper compared to having a second round of certification with a test house. And also what I have shown before is the 2D, 3D radiation patterns and the composite gain and MIMO system optimization. And I think especially this is coming more and more for Bluetooth and all these direction finding technologies. So we use it for also for Wi-Fi throughput measurements. And as I said, these composite gain measurements to optimize every antenna design. And coming back to the main parameters, which I mentioned in the beginning, just some more some more slides on how we measure, how we provide it. So we have like the return losses, isolations, gain, efficiency, and polarization with our many different measurement systems, measurement equipments. We usually provide these kinds of reports and the test results in an official report, so we can optimize exactly each individual case. It might be just shifting the frequency to the right frequency, center frequency. It might be just optimizing the efficiency a little bit. It might be just comparing the active tests for human body absorption, for example, or having these kind of gain improvements, because as I said in the beginning, it is quite important for low energy technologies to have a really, really good antenna and the optimized antenna to save the energy that is coming in with the low energy technology like BLE. And as I said as well, these composite gain measurements and isolation measurements, all that we can do in our chamber. And this is another example of some customer who failed the certification due to the harmonics. So it was not only the 2.4 gigahertz band and the gain and the 2.4 gigahertz which caused to fail the certification. It was actually the harmonics that built up in the second resonance here quite late in the 4.6 gigahertz roundabout, which is of course blocked for other bands, potentially in other areas. So we analyzed the problem. We found the root cause, why this harmonic is building up, and we adjusted the matching circuit, and we were able to remove this harmonic and really make it easier for the customer and make it possible for the customer to pass his certification. And also here with more antennas, more antenna arrays, this will be more complicated. So feel free to use our services, our manpower to optimize your antennas in your design. It's quite easy, quite fast. We have, as I said, the design centers worldwide where we can do exactly these measurements and exactly these optimizations. So you can save some costs on not doing it yourself and just go quicker to the market. Last but not least, we also have a lot of online tools and online resources on our website. Typically, this includes all the design tools that are required to integrate an antenna. It's beginning from the data sheets, including the description for the mounting. Could be especially interesting for the SMD type antennas and also the metal stamp antennas, how to integrate them. We have application notes additionally for many parts, having different tests, as I have shown, for example, on the position of the antenna, as I have shown on the influence of the orthogonal layout of the antenna, or maybe just some surrounding checks and how to mount an FPC antenna. We also have all the 3D files typically available. If they're not online yet, you can always ask for it as well, and we will share it as well. We also have like our tool search. We have some antenna references for chip and modules from different brands. We have our sample kits and sample boxes. So on all exhibitions, we are usually sharing these, and much more technical resources like white papers, flyers, brochures, videos, and case studies on our website. We're also working with an IoT solution optimizer, even though it's a focus on IoT and the low power wide area technologies. We always recommend to take a look here because you can simulate a whole device from start to the beginning, from start to the end, including the antenna, the module, the batteries, surrounding areas, if it's a deep indoor or outdoor application, and you can really optimize the whole device here as well with a very, very huge database that is integrated here. And yeah, that's about it for this webinar. I just wanted to highlight we have a huge RF knowledge and extensive experience in customizing, but also standardizing antennas, using the antennas for challenging environments, challenging mechanics. We do offer validation, optimization, and pre-certification services. And we have a quite innovative roadmap coming up with more antenna arrays and more eval kits for antenna arrays for BLE direction finding and BLE channel sounding. So stay always up to date. Follow us on the known channels and connect with us so we can always stay in touch and optimize maybe also your application in the end. So thank you everyone for the attention, and thank you again, Tobias, for having the chance here to speak up and have this nice webinar.
Thank you very much, Jens, for your great presentation and information. We do have some questions. I would like to jump straight to the Q&A session. First question is, how distinguished in the RTT method whether a reflection is direct or the result of multiple reflections from other object located at the site?
Well, usually we can figure it out by the frequency and yeah, whether the frequency is in a similar range or not. And from the experience in our design team, we can distinguish if it is one or the other channel based on the measured results of the reflection.
Okay, thank you. What are the influence factors of cabled antennas for locationing?
So one of them is of course the cable itself, and that's why we more and more have applications without cables for these FPC type antennas, but rather spring contacts, for example. Another influence factor is, as I said, the environment where it is mounted on, but also the cable losses in the cable, and also the mounting position and the mounting angle to the PCB, similar to the SMD type antennas. The FPC and PCB type antennas can be mounted vertically or horizontally to also cover the different polarizations in the field.
Okay, thank you. How to approach KYOCERA AVX to get measurements?
So I shared my contacts in the presentation, but you're always also very free to contact Rutronik at this point, the local sales at Rutronik or our local sales as well. As I said, we are usually present on all the bigger exhibitions, so you can reach out whenever you need. Or we have a very nice online contact form, which immediately will be distributed within our regions. So it will come to me after a few hours, and I will reply immediately once I read the email.
Okay, the last question I see for now is, what are the costs for custom designs?
That's a very, very interesting question, and always the answer is it depends. It really depends on many factors, like the complexity of the design, the parts that are being used, if it's a SMD type antennas, or if it's an FPC antenna which has to be customized, or as I said, LDS antenna. Depending on that, we have to figure out how complex the adaptation will be for a customization, how the tooling costs and the manufacturing costs will be shared and built up. And it of course also depends on the quantity of the product itself, on how much it will cost in the end. On our website, we have a very nice overview on the services. So you can just type in antenna services and you will have a very nice overview with certain part numbers that you can request for quotation and then have a quotation for each single measurement, for each single service that we offer, or for the different phases on the measurement itself.
Thank you very much, Jens. These are all questions for now. If you have any further questions, don't hesitate to contact us and we will answer you afterwards, of course. Just few slides at the end of our presentation. I will share my screen again. So I hope you can see my presentation now.
Yep.
If you want more information, you can check out our rutronik.com webpage, also our Rutronik 24 online shop, and our Rutronik tag, where when you are up to date. Also, please follow us on social media. We are on LinkedIn, Facebook, Instagram, and YouTube. If you have further questions, you can, of course, contact me. You can find my contact information on the left side, or, of course, your Rutronik sales area manager. Also, you can fill out a contact form you can find on the right side or on our rutronik.com webpage. Here you can see our further webinars. Today we had KYOCERA AVX. Tomorrow we will have Inside SIP with upgrading your BLE capability. And on Friday at the end we have Infineon with BLE chipset and module. So if you want, you are welcome to join our next webinars. I want to thank you, Jens, for your presentation and your great information. I want to thank you all for your participation and wish you a great day.
Thank you. Bye.